Hi, this is your video for explanation of derivatives day one notes. So if you are following along with the notes with me, differentiation is what we say with derivative. If you're differentiating, you're finding the derivative. It's the process of finding derivatives, which are defined as limits of difference quotients. There's three different notations for the first derivative. One of them is y prime, one of them is f prime of x, and the third one, the most common one, looks like that fraction dy divided by dx. That's the most common notation that college textbooks use for the first derivative, and you say it dy dx. And then underneath that, the definition for the first derivative, we've already done that. We did that back in October, where you do the difference quotient and you find the limit of the difference quotient as h approaches 0. Remember from your limits unit that we just finished, you simplify the function completely and then at the end you replace h with 0. So derivative rules. I'm going to run through these pretty quickly. Most of what we're doing today is review. So derivative rules. Rule number one, if f of x is y equals c is a constant, like y equals 5, it's just a horizontal line at y equals 5, it's a constant function, then the derivative is 0. So, for example number one, the function is f of x is equal to 3, and we're going to find the first derivative. This just kind of verifies or proves that the derivative of a constant is 0, which, by the way, be careful, because we just finished limits. The limit of a constant is the number itself is the constant, but the derivative of a constant is 0. So I could write this function adding in x raised to the 0 power. It's the exact same function because anything to the 0 power is 1, and 1 times 3 is just 3. And then if you follow your rule for the first derivative, you can either use f prime of x, y prime, or dy dx. You multiply the exponent times the coefficient, so the coefficient becomes a 0, times bring your exponent down by 1, x raised to the negative 1. So the first derivative, dy dx, is 0 times x to the negative 1 is 0. So the derivative of a constant is 0. Example number 2, you know this already. We've already done this. This is just really your shortcut rule for derivatives. If your original function y equals 5x to the 4th, or f of x is equal to 5x to the 4th, y prime, f prime of x, dy dx, they all mean the same thing. They're all notations for the first derivative. You just take your exponent, you multiply it by the coefficient, bring your exponent down by 1, so the first derivative is 20x cubed. For number 3, rule number 3 for derivatives is sums. If your function is made up of two separate functions, u of x and v of x, that are getting added together, then the derivative is just the derivative of both of those things getting added together, which is, again, something that we've done already. So for example number 3, the function f of x, or y equals 6x cubed minus 2x squared plus 3, this function is really the sum of three separate functions. One function is 6x cubed, one is 2x squared, and one is just positive 3. So if you have a function that's the sum or difference of functions and you're taking the derivative, you just do the derivative of each piece of it, which again is review. F prime of x, again you can use dy dx, f prime of x, or y prime. Use your shortcut rule. 3 times 6 is 18. Bring your exponent down by 1. 2 times 2, the coefficient here is the negative 4, x to the first. You don't need to write the 1. The derivative of a constant is 0, so the first derivative of that function is 18x squared minus 4x. The product rule is brand new, and I'm going to show it to you, but we're going to go over it again in a couple of days. Today, you wouldn't really need to use the product rule. You could just multiply the stuff together. So for example number 4, your function f of x is equal to x plus 2 times x minus 5. This is the product of two separate functions. One function is x plus 2, one function is x minus 5. If you just multiply these together with FOIL and take the derivative of each piece, you're going to get the same answer as if we use the product rule. The product rule will become more important again in a couple of days. So one way you could do this without the product rule is just to multiply these using FOIL. So first times first is going to be x squared. Outside is negative 5x plus 2x. You get a negative 3x. And then when you multiply last times last, minus 10. That's the function multiplied. And then the first derivative, f prime of x, you would take the derivative of each piece. This is going to be 2x to the first. Bring your exponent down by 1. The exponent here is 1. 1 times negative 3 is negative 3. X to the 0 is 1. And the derivative of a constant is 0. So that's the way we would have done it before. But the product rule. Okay, so here's our original function again. F of x is equal to x plus 2 times x minus 5. Now I'm going to do the exact same thing using the product rule. I'm going to show you we're going to get this same answer. Okay, so what the product rule says, if you have a function u of x times v of x, two things getting multiplied together. So the x plus 2 would be u of x, the x minus 5 would be v of x. These two functions are getting multiplied together. Using the product rule, you take the first function, multiply it by the derivative of the second function, plus the second function, and multiply it by the derivative of the first. So let me show you the same question using the product rule. So the first derivative, f prime of x, is going to be equal to the first function, which is x plus 2, times the derivative of the second function, x plus 5. The derivative of x plus 5, this 1 times 1, and then x will go down to the 0 power, the derivative of negative 5 of 0. So the derivative of the function x minus 5 is just 1. So here's the first function times the derivative of the second, plus the second function is x minus 5 times the derivative of the first function. The derivative of x plus 2 is just 1. So the first derivative, x plus 2 times 1 is just x plus 2. X minus 5 times 1 is x minus 5. When you combine like terms, the first derivative is 2x minus 3, which is exactly the same thing that we got by multiplying the functions together. Now, if you have something that's as easy as just two binomials getting multiplied together, using FOIL and taking the derivative of each piece is a real straightforward, easy way to do it. But what we're going to get into in a couple of days is these two functions that you're going to be multiplying together are going to be a lot more involved, and then you will have to learn the product rule. So let me go through the product rule one more time. This is my first function, x plus 2. My second function is x minus 5. Using the product rule, you start with the first function, which is x plus 2, times the derivative of x minus 5. The derivative of x minus 5 is a positive 1, plus the second function was my x minus 5. This is the derivative of the first function, the derivative of x plus 2, and then you just simplify. Okay. Example number 5 on the back. It's kind of straightforward again, and it really just follows a shortcut. But example number 5 is saying that the function f of x is equal to 4x squared. When you have a constant times another function, this is really 4 times x squared. I know we don't usually look at it like that. You can find the first derivative, dy dx, as saying 4 times the derivative of x squared, which is 2x to the first. So dy dx is equal to 8x. And that's what we would have gotten if we had just done the shortcut rule from the very beginning. Okay, now for example number 6, I did not do the last 2 days of limits, and the last day of limits is called instantaneous rate of change. That's such an involved lesson that I just really chose not to do it from home. If you're a junior and you want to come in at the end of next school year and learn the limits lesson on instantaneous rate of change and velocity, please feel welcome to come back. But instantaneous rate of change, what you do is you take the first derivative of a function, and then to find the instantaneous rate of change at a certain x value, you take that x value and you plug it into the first derivative. This is going to have an impact on what we're going to do in the next few days. So for example number 6, find the rate of change at an x value of 2 and an x value of 4 for the function f of x is equal to x squared plus 3. Okay, so if our function is f of x is equal to x squared plus 3, and I want to find the instantaneous rate of change at an x value of 2 for this function and an x value of 4 for this function, my first step is to find the first derivative. So f prime of x will be equal to, I'm going to use the shortcut rule, 2 times 1 is 2, bring the exponent down, x to the first, and the derivative of a constant is 0. So 2x is our first derivative. To find the rate of change, the instantaneous rate of change at an x value of 2, I'm going to plug 2 into my first derivative. So again, I'm using my first derivative, f prime of 2 will be equal to 2 times 2. So the instantaneous rate of change of this function when x is equal to 2 would be a positive 4. You're also supposed to find the rate of change at x equals 4. So the rate of change, you plug 4 into the first derivative. It's going to be 2 times 4. So the rate of change, or instantaneous rate of change, means the same thing. At x equals 2 would be 4, and at x equals 4 would be 8. The last example is doing a first derivative using a shortcut and using the definition. Part of your homework is to do derivatives by definition, and when you do the definition, that's the really long process that we went through back in October, where we're going to do the difference quotient and then the limit as h approaches 0 of the difference quotient. So I'm going to go through the by definition part and then real quickly go through the shortcut, and that'll clear up, finish up our notes for today. So we're finding the derivative of the function f of x is equal to 3 over x by definition. So this is the long limits way to do it. So f prime of x, the first derivative, is equal to the limit as h approaches 0 of the difference quotient, which is f of x plus h, minus f of x over h. Now, I alluded to this quite a few times during the limits chapter. You keep your limit notation until you're done simplifying the function. Every place I see an x in the function, I'm going to replace it with x plus h. So f of x plus h will be 3 over x plus h. So I've done this, minus my original function, 3 over x, and the whole thing divided by h. I've made a small error. If I can find my small eraser. This should be as h approaches 0. Got to change this to an h. Okay, so if I were to plug 0 in for h right now, this would be undefined. But we're going to simplify this, and then when we're done simplifying, we're going to replace h with 0. So there's 3 fractions. One has a denominator of x plus h, one has a denominator of x, one has a denominator of 1. I'm going to clear the complex fraction by multiplying everything in it by the LCD, and the LCD is x times x plus h. So I'm going to multiply this, x times x plus h, multiply this fraction, x times x plus h, multiply my denominator, x times x plus h. Right? first derivative is equal to the limit as h approaches 0 of the x plus h's cancel, so we have 3 times x minus the x's cancel, so I have 3 times x plus h. In the denominator, nothing cancels, so I have h times x plus h. I'm not going to distribute that yet. I'm going to wait and see what I have after I clean up the numerator. I'm going to simplify the numerator. The first derivative, f prime of x, is equal to the limit as h approaches 0 of, distribute the negative 3, 3x minus 3x minus 3h over h times x plus h. Again, I'm not distributing yet. These 3 x's cancel, so the first derivative, f prime of x, is equal to the limit as h approaches 0 of negative 3h divided by h times x plus h. The h's cancel, so the simplified form of the function, keep your limit notation in there, f prime of x is equal to the limit as h approaches 0 of negative 3 over x times x plus h. We're all done simplifying the function. Here's where you drop out your limit notation and replace h with 0. So the first derivative, f prime of x, is equal to negative 3 over x times x plus 0. So the first derivative, f prime of x, is equal to negative 3 over x times x is x squared, and in our first derivative, x cannot equal 0. Okay, so that's a lot of math. That's your by definition. I'm going to do the shortcut rule in red right next to it, and I'm going to show you that we're getting it the same way. So that was part A. This is part B by using the shortcut. So our original function, y is equal to 3 over x. Remember that this x that's down in the denominator, I could write it in the numerator with a negative exponent. This is 3 over x raised to the first. So I could still write the original function as 3 times x raised to the negative 1. That's the same function. That's my original function. If I use the shortcut rule for the first derivative, y prime is equal to the exponent of negative 1 times positive 3 makes my coefficient negative 3x. Bring your exponent down by 1, raised to the negative 2. The only thing that's getting raised to the negative 2 power is the x. So the first derivative, y prime, is equal to negative 3. The x comes down in the denominator with a positive exponent, and you still have to include that x cannot equal 0. Of course, the shortcut is the easier way to do it, and it's a good way to check. But if the directions are find the derivative by definition, you do have to go through all of this. So everything I did today is review, except for that instantaneous rate of change. And we're going to use that to write the equation of the tangent line. So stay tuned for that. I hope you're doing well. I know that on Friday, the governor decided to close schools till the end of the year. So this is going to be the way we're going to run this class till the end of the year. This is our last chapter. Next week, Tuesday, I think, is May 12th, is our last day of new notes on integration. And then one day next week, you're going to have an online test on derivatives and integration. And then we're going to review. And by Monday, I hope I have a very definitive answer by Tuesday. You're going to watch this video on Monday. By Tuesday, by tomorrow, I hope a very definitive answer about your final exam. Just a quick reminder too, guys, if your stuff isn't done by the end of the day that it's assigned, it's just a 0. You really have to log on and spend about a half an hour to 45 minutes every day for this college class. Most of you are doing a fantastic job. and I'm so proud of you, and I miss you. I know this is hard. It's hard for all of us. But stay positive, and we'll get through this, and I am looking forward to seeing you somehow, some way soon. Take care, everybody.